probably got logged out, so let's log back in. Last time we had, on Monday, we were talking about like career fair and kind of what skills we have, just, and these are pretty broad skills from this class, but thinking about like what have we actually done and how does that translate into like technical career competencies. So the best, and this is advice that I give everybody, especially engineers applying for jobs, is like do your best to like quantify what you've done. So if you managed a project, like someone gave you a project and you managed it, that's good, but what specifically did you manage? Was it a $10 million project? Was it $100,000? How many people were there? How many meetings did you have? Like, was it a weekly meeting that you were organizing people? So there's ways where you can kind of take a broad sort of like, I did this thing, to I did these like specific measured things and that led to something. Usually there's like an output for the company, like or yourself, like you did XYZ and now things are 5% more efficient compared to before. But anyway, taking kind of this class and doing the same kind of analysis, you can talk about like how many Jupyter notebooks you created that are open source, how many notebooks you've run, like how many you evaluated and you ran. Talk about like numerical versus categorical data and like visualizing that in Matplotlib. But anyway, I wanted to bring that up again because it is important. We are building like career skills. Let's see. All right, here we go, back in. Okay, what are we working on today for computational work? Homework? Any part of the homework? Or, oh wait, wrong class, my bad. Here we go. O2. Homework 2. This was one thing we figured out last time. His name? Sorry, I'm scrolling back and forth, but if you have NA values, then box plot, then you can't actually make a box plot of stuff. I think in the year 2017, whether or not you remove those NA values, it won't make a difference, but we would need to say like dot drop NA. So this would be like year 2019 box plot, and then year 2017. Is that 2019 or 2018? We could check 2019. So 2019, 2018. Usually box plots, you would want to put them on the same plot, but so you could actually compare where the like visually see what the difference in values are. But I was just showing an example on Monday about how to grab just a subset of your data frame. Where data frame is just like a fancy way of saying like that table of values. So it's a table of values, and there's all different ways that we can like process that data to visualize what we want. Yeah, because you're still using, like if you're using 11 time steps over 24 hours, every step is like an hour and a half, 2 hours, 2 something. Yeah, you could, like if you're multiplying 3 by 8, then you could, you could say n is 8 times that. But if you want the same delta t steps, because yeah, you're right, they're both connected. Time step with 0.1 hours will give you a certain convergence, splitting up a different amount of time to take these steps. To see in this example, there's like a column called designer. So Apple, AMD, IBM, they all made those chips in different years. So color coding them. Yeah, so we can kind of see like the categorical and numerical. So it's got years and transistors. Kind of figure out like who's using what transistors within here. So can I change this So that one, this one's a little different because what we did was like take a whole bunch of categories and like average all the data. So we like grouped, and that's what that group by command does. Like, so that would take like all the IBM data and turn it into like one average transistor. But here we kind of want to keep everything separate, but we do want to show. But I've seen group by work to group by, but then plot all the results anyway. Or you can do what we did with like that 2017 data, show me all the IBM data, plot that, and then show me all the AMD data, plot all that. Or get like subsets of it. Yeah. Yeah, and the dots you can get even down here. Just scroll down. If you in a semicolon divide, there you can put a comma. Oh, sorry, inside. Put a comma and then go like an O inside quotes or something. Now it's all dots instead of connecting lines. You know, put an O and a dash and make them connected dots. You can. There's tons of color maps, and there's already default colors. So if you plot three things on one chart, you get 3 different colors. I'll show. All right, cool. A couple things came up. One was, so because we're running like Jupyter and Python, Jupyter's free, Python's free. You can run this, like we have everything set up on our NanoHub server, so you can kind of log in and everything's like a little playground where you can work in. But you can work on this on your own computer. And you can even like maintain your own version of this website if you want. And so if you go to this like little waving octocat at the top right in our website, it brings you to like an actual GitHub repository, and it's where all the source code is for this class. So there's little things like, oh, how do I find the data? And there's a folder called data, and we have like all of the, there's even some extra data sets that I used at one point and like kind of got left there. This one's kind of cool, like if you want to see a logistic regression case, the Challenger O-ring is kind of a cool data set of like, what is the chance of failure for an O-ring based on temperature outside? But anyway, so there's all this stuff. So you can download stuff individually, and that's a good way, even if you like totally bork your Jupyter notebook, like you delete everything and nothing works, you could go into this and say like, all right, let me get that homework 2 again and totally start from scratch. But we can also, you could download this whole thing, like download a zip file, or you can like clone, it's called cloning, where you take a repository and like make a copy on your own computer, and you can also make a fork of this copy. I used to tell everyone that they had to fork the repository, but I'm trying to like limit how many things I make you sign up for this time. But if you have a GitHub account or you want to try it out, you can fork a copy of it, and now it's yours. Like you have your own version of this website. So that was one thing that came up. Then the other thing was we're taking a look at, and let's do X that. And I want to get rid of all that. So in this second, so first we make a box plot just to see like what does the data look like for 1 year. And then next we want to look at all of the transistor data, but we want to color code it for each designer to see like when did IBM start making processors, or has Nintendo been making transistors since 1981? So just like a little bit more, so it's a combination. There's numerical stuff that we want, but also some categorical, like what are the categories of stuff. So in that case, let's see, I want to get rid of this one. First, let's just try let's just leave it like that. So if I just take all the data, plot it, there are some missing values. Anytime you have an NA value, you'll have like a break in a line. So sometimes you want that, other times you don't. I don't really care about the connecting lines because I don't think that there's intrinsically a line connecting 1 year to the next with transistor data, if that makes sense. Like it's just a cloud of transistor count. So I don't really care what those lines are. So let me get rid of them. I'll just put circles everywhere. And now I don't have those distracting kind of zigzag lines. And I can now it's a little easier to see, like there's some kind of trend that every year exponentially more transistors on each processor. And the way that I approach this is always trying to figure out like if I wanna plot individual like designer data, let me start by seeing if I can do it for one designer, and then I can always create a loop and do it for every designer. That's, at least this is the way that I think about it. It's like, if I can do it once, I can do it 1,000 times. Like, that's the whole goal of like programming. Create a process and then kind of automate the process. So let's see what that process looks like. Let's call it like my data. And to start, let's look at all. Can I get all the values? Anyway. All right. So we've got designers, and so one way is just like plot each. I could plot like one row at a time and label and give it a label. Like, here's my label is the designer, and the data point is year and count. But I can see immediate, like just from these first kind of 4 or 5 rows, Intel shows up 3 times. So if I do that in my legend, I'm gonna have, even if I only plotted these kind of 10 data points, there would be 3 Intels, 3 AMDs, 1 Garrett Research, 1 Amazon. It's like, all right, well, I don't want Intel to just like soak up my entire legend. I only want one version of Intel. So how many Intels do I have? A bunch. Like, okay. Couple of trues. And if I say like, take the data frame and grab every row where this statement is true, that designer is Intel, now I just have a data frame. It's the same structure as my previous data frame, but there's 62 rows instead of that full 186. So Intel makes up like 1/3 of this data, or 1/3, yeah, about 1/3, because there's 186, and 62 of them are Intel values. All right, so let's try that. I'll say, I'm gonna merge this back down here, merge. So this isn't everything, this is just the Intel data. So now it's just a subset of like what was Intel doing from 1970 up through 2019, I think. Cool. So I can do it once. Can I do it twice? Let's give it a shot. Let's try IBM. So IBM didn't start making processors until 1982, 1981, and then took a long break, and then 2005 came back hard, started making some processors. I think they don't make processors anymore, anyway, for IBM. So already I can kind of see if I just plot, if I ask Python to just keep plotting, it'll change the color for me. If I want a little more control over that, I can work on that, but to start, I can just try plotting everything. So that means really what I need is a list, like some kind of structure that has all these names in it. Intel, IBM, Nintendo, Garrett AI, like all that stuff. So I don't want all this stuff. Really what I want are the unique values. can create, now it gives me this array full of everything only shows up one time. And I can say my data is going to be just the AI, just the Intel, just the NEC. If I want, I could sort it. I think that'll work. Let's call it like designers. Now it's alphabetical if I want alphabetical. Or maybe I want to sort it by like the number of processor, I don't know. But alphabetical's fine, it's a good start. So instead of running one by one, I'm going to take all this, put it inside of a for loop. And instead of just saying it's equal to Intel, I'll say that it's equal to designer. Now there's definitely all the data's there. It's all colored, but it didn't actually keep track of who's who. That would be that would be good information to have, I think. I don't know, maybe you disagree. It's like, it's completely obvious that this is, I don't know, an AMD data point down here. I don't see it. So let's add a label to each of these. And we'll just say the label is the designer. This gets a little ugly because it tries to find the best place for it, but it's assuming you only have like 4 or 5 different things. So we got to do a, oh my God, is it set bbox or bbox to anchor, I think. I've had to look it up 100 times. Just to get it out of the way. But bbox to anchor is like manually put the thing where you want. A 100 is saying like 100% up, 100% to the right, so get it outside. If you say like 0.5, I think this is left, right first. Yeah, so it makes it like halfway and tries to get it to the top of the figure. So let's go back to 1.1, get it outside, and a 1 up at the top. And then there's also, in this one, I think, rows and rows? No. Now I have to look it up. Or N calls. Is it N calls? Ncall. Yeah, it is NCOL. Now it's looking a little better. Starting to get there, right? Data visualization as a whole, like, it's definitely a science. Like, there is a science to like processing data, getting it into the right form, and like a lot of math. But there's also a lot of like artistic intuition that you can put into it. If you don't want to put into it, then that's okay, but it's a good chance to like practice being a little creative. So one of the things that might bother you, at least it bothers me sometimes, is like AMD, Bell Labs, Hitachi, NVIDIA, MIPS, and then there's a few other hidden under our chat. All of them are blue dots. It's like, well, so who is who? What dot is which? And there's more than one way to fix this. We could create like same way that we did that home reading number 2 creates like a color scale, and we could assign each one to a color scale, or we could cycle through different markers and different colors. We could have like 8 different markers, 8 different colors, and now between colors and markers we have 8 to the 8 different combinations. And that's more than enough. Well, then we need a list. So let's go Copilot. And do we want to, there we go. We can go into our Learning Coach module 2. And this is one way. I mean, there's probably like Stack Overflow discussions where you could get this too, but a list of 8 markers and 8 colors, and now we could like cycle through each of them. So we'll say IM equals 0, I color equals 0. And we'll go, should we cycle through markers first or colors first? What do you want to do? Doesn't matter to me. Or try both. What should we try first, markers or colors? Because my idea is like, we could increment each one of like, make it a blue circle, and then a green square, and then a red triangle. But my thought was make 8 blue markers and then 8 green markers. Or we could do back and forth of like blue circle, green circle, red circle. What do you want to do? What do you think would look better? Yeah, try it. Is more than 7. 0, 1, 2, 3, 4, 5, 6, 7. Oh, I messed something up. Oh, I need some commas in there. There we go. how does this look? Bunch of blues, bunch of greens, bunch of reds? Or do you want the colors to change first and then markers? And then get rid of lines, right? I think we can say line width equals 0. That looks a little better with no. And we could say marker size, increase marker size, right? Let's try 10. Keep forgetting those commas. 10's too big. I don't love the cyan. I'm gonna get rid of it. A little, looking better, right? Yeah, and there's more than one way to do this, but this is one way of like specifically set out, these are the colors that I want to use, and let me cycle through those. And we could try this. Let's switch them. IC, IM. Oh, I removed one of the colors. Circle, circle, dot, dot. Now I have my transistor shot. But now it's cycling through colors and then markers alphabetically. I don't know, I kind of like the banded colors a little bit more. But it's also an example of like where it kind of makes sense to use AI. Like these colors and markers have been used millions of times across different Python codes, but they're usually not in the form that you need them, of like a list, or maybe you need them in a different, maybe you need them in an array or something. So AI can kind of reformat them and put them right into the form that you want them. And then you can plug it right into code, and we can choose markers, choose colors, get rid of the lines. I could have just written these out, right? Like if I already knew what markers were available, but sometimes it's nice to save a little time. Anyway, that's like one kind of like 0 to graph, start to finish cooking kind of lesson. Other things coming up as you're kind of working through. Four B, like part 4? Yeah. So in like the trying to calculate pi, or? Oh, part B. X locations? Yeah, because the middle, like where it lands, if we think of it as like the needle is a rigid body, where it lands is its X position, and then the theta is telling you like what orientation it's at. So maybe it landed at like 0.1 away from either line, but it's at a 90-degree angle. So then it's not going to cross anything because it's parallel with that 0. So we got 2 minutes. Let's give it a shot. And I'm going to call it N. I'll start off with 10. You don't have to show what they look like, but I just and then what do I want to do? And then I'm going to do this. So we can kind of see like how these things land. Thinking about like X positions can be 0 to 1, Y positions can also, we don't care about where they land up or down. So we don't actually need to calculate where they are. But if you imagine like you drop these things and they all land on 0 to 1, X and Y, then from this I can kind of see like, all right, I have 1, 2, 3, 4, and 5, maybe 6, 7 of them crossing that 0 line. And so that tells me like 7 out of 10 is the number that I was looking for in this Buffon's needle kind of experiment. It gets harder to see as we go up to like 100, because now it's just like rat's nest of stuff happening. But the more needles you drop, the better calculation of pi you would get. And it does look kind of cool, like a koosh ball. I don't know if is koosh ball still a thing for kids? No? It's like a 90s thing, maybe. You had one? Yeah, they're cool. Cushy. Oh, all right. I went over time. Thanks for staying. Thanks for looking at my koosh ball. These are the important things in life. Oh, and then Friday we'll be off again. Come back on Monday. Does that sound good? If things come up, post in like Husky CT, like we have discussions. Yeah. When is it due? homework 2 is oh, it says tomorrow. This has been a busy week though. Seems like nobody is ready. We can push it. Let's push it back to like the same as the project. Yeah, let's push like project back to Friday or something, and then this one like, yeah, Wednesday, Thursday. That would make sense to me. Thanks.
I don't know if you'd have a little information on this, if you've ever seen this before.
Maybe.
So they totally screwed me over with the whole schedule for the spring.
For spring?
Yeah.
I'll stop this in a second. Let's see. Make this one not this Friday, next Friday. We'll try that. Okay, cool.